what we're starting off with is the greatest unit of all time. Perms and comms. It is very wordy, and I despised it in grade 12 myself. But it was because it was very wordy, and I didn't know the difference between a perm and a comm. And if you don't know the difference between a permutation and a combination by the end of the unit, it's really hard, because you could be guessing the whole time, which was me. So I made it my goal in life that you don't feel the same way I felt when I was done the unit exam. Not that my teacher wasn't good. My grade 12 teacher was amazing. I just didn't. I was like, it's words, I don't like them. I'm not going to try hard in this one. I'll do the rest of the units really well. Not a good way to go. Just saying. Okay, so on the front here we have order matters and order doesn't matter. It's at the very title page. It's going to make no sense to you because you've learned nothing currently about this. But permutations, order matters, and we'll come back to this at the end of the unit as well. And combinations, order doesn't matter. So for example, order mattering would be like words. Because you could have the word pool. And if you exchange the letters, you get lopo. I ain't the same word. Lopo isn't even a word, but maybe it is. I don't know. But they're not the same. So the order in which you lay those letters out matters, right? You get different words with it. Yes? But, for example, if we were going on a, and this isn't like, you don't have to pull out your word paper and be like, is this a word or not? Like, it's just distinct arrangements of letters is what we, like, when we say words. It's not actual words. You don't have to bring out your, like, Scrabble tile book. So, no. Yeah?
So if you were adding dyslexia, is it really sad?
Well, no, because we're not actually figuring out the real words. Because loco and loop and cool and olo are all different. But this is actually a really great place to have a little bit of problem reading. It don't matter. All right. So, when order doesn't matter, it would be like if you were going on a trip and everyone got to go on a trip to Narnia. Who wouldn't want to go on that trip? You know what I'm saying? So you get to go on a trip to Narnia, or you don't. So the first 4 people I pick get to go to Narnia, or they don't. If you're number 5, no Narnia for you. Okay? So did 1, 2, 3, or 4 matter if you were picked first, second, third, or 4th? No, you all got to go to Narnia. Okay? But if I gave you jobs going to Narnia, like number 1, you have to find the witch. 2, you have to find the Tin Man. 3, the lion, and 4, you just got to go with for fun. I want to be number 4 first off. I don't want any responsibilities. Then order would matter if you picked first, second, third, or 4th, correct? And then it would be a permutation because I would want to pick 4th because I wouldn't want responsibilities. All right. So we're going to first talk about permutations and the fundamental counting principle. So if we consider a task made up of several stages, if the number of choices for the first stage is A and the number of choices for the second stage is B, and the number of choices for the third stage is C, then the number of ways that task can be completed is A times B times C, and this is the fundamental counting principle, which sounds convoluted and weird. But we're not going to stop there and be like, now you understand the fundamental counting principle for life. You're welcome. We're going to go do an example. So here we have a toy manufacturer, and they make a wooden toy in 3 parts. So there's part 1 is the top of the toy. It can be colored red, white, blue, or pink. Part 2 is the middle part, and it can be colored orange, purple, or black. So there's 3 colors. And part 3, the bottom part can be yellow or green. We need part 1, part 2, and part 3 to make this toy. You can't just like pick part 1 and have the head of the toy. And it's cool, we have the toy. We don't. So we have to have part 1, 2, and 3. Now, we're going to determine how many different colored toys can be produced using a tree diagram. We're going to do the tree diagram first, because the tree diagram will actually show you the different outcomes of what the toy could look like. Fundamental counting principle isn't an answer that fast. But then you would just be trusting me that that is the answer, but not seeing it. So we're going to visualize it first in a tree diagram. Now the tree diagram itself is more like a horizontal anti-gravity bush. Not really a tree, okay? You guys try and draw it as a tree the whole time, even though I tell you it's not. You will on the homework. So let's not. Prove me right. Prove me wrong. Prove me wrong that you're right. Yeah. So, Tree diagram, you would think, oh, we start at the top of the tree and we work our way. No, it's an anti-gravity bush. It's you start at the side and you work your way this way. You know, like it's if you took the tree and you flipped it on its side. Okay? So we're going to start off with part 1. And if you draw the parts along the top, then you might draw your tree correctly. If you're drawing it and it actually looks like a tree, just know that you're wrong. Okay? If you're like, wow, this is a really nice looking tree, then be like, I'm wrong, and start again. Okay? So, part 1 has red, white, blue, or pink. So I write the options below it, and I'm going to leave a bit of space between each of the words because I'm going to have branches coming off of those words, going like this, right? If I don't leave space, I'm not going to be able to write those branches. So, do as I do. So I'm going to go red, and then I'm going to leave a little bit of space, and I'm going to do white, and then I'm going to do blue, pink. I believe I was a rebel in high school or something, because when my teacher told me to leave spaces, I didn't. Like, why listen? I don't know. I still remember not doing that. I still remember doing slope. You know slope. Y2 minus Y1 over X2 minus X1. I had a daily quiz. I got a 0. Want to know why? I labeled my coordinates X1, X2, Y1, Y2. Not X1, Y1, X2, Y2. Because it's an X, then a Y, then an X, then a Y. Like, that's how it is. I wrote X1, X2, Y1, Y2. And if you fill that into your formula, every single one's wrong. I still remember to this day, it was grade 10. It was the worst day of my life. It was terrible. I had a sad day. I had nothing right. I was like, what was I thinking? So if you ever get a 0, don't worry. I'm your teacher. And I got a 0 on a test. You're welcome. This is going to be a great year. All right, part 1, red, white, blue, or pink. So if it only had part 1, we'd get 4 toys, right? We'd have a red toy, a white toy, a blue toy, a pink toy. We'd be done. But it's not just one part. There's part 2. So part 2, I'm going to label along the top. How many parts does part 2 have? How many options, I should say? 3, right? So we go like this. This one's going to have 3 off of it. That one's going to have 3. You didn't leave space, did you? Mr. Oh, I warned you. I take no blame on you having to erase those 4 words. Okay, part 2. Part 2 is orange, purple, or black. So I'm going to have orange. And I'm leaving a bit of space off of these ones, trying to, in between them, because they're going to end up with branches off of them for part 3. That is not orange, black, orange. Orange, purple, black. So if this toy only had 2 parts, how many different toys would we get? Ish, yeah, we get 12. A lot-ish is correct. Or 12. Yeah, we get 12 because we'd have a red, orange toy, red, purple, red, black, white, orange, white, purple, white, black, blue, orange, black, purple, black, blue, black, pink, orange, pink, purple, pink, black.
Sorry, I'm crazy.
Yeah, you should be. Didn't even notice you were talking, but yes, learn from your mistakes. All right, part what next? Because there actually is another part. Part 3, how many options does it have? 2. Oh yes, I feel you. My inner grade 12 Crystal would have been really annoyed that I would be writing these all out, but you're welcome. My inner 40-some-year-old Crystal doesn't care. So write them all out. What options do we have? Yellow and green. I'll be nice. If you want to, you can go Y and G. And why am I saying that? Because I don't want to write them out. Now, normally, what I would do is make you write out all the outcomes. So you would have to tell me, okay, the first outcome could be red, orange, yellow, right? That toy would look like red on the top, orange in the middle, yellow on the bottom. Then I would have red on the top, orange in the middle, green on the bottom. Then I would have red on the top, purple in the middle, yellow on the bottom. You know what I mean? So how many toys would we get? 24. So what math did you do so that you didn't actually have to, if I didn't want to have to draw this out, what math would you do? You would do 3 times, sorry, try again. 4 times 3 times 2. Because you need every single part, correct? Now this is the key thing. If I use the word and, I'm going to multiply. So I'm going to write this here. I'm going to write and multiply. As a little caveat for my brain. So if I need part 1 and I need part 2 and I need part 3 to make the toy, I'm going to multiply all those parts because I need this one and this one. If I needed part 1 or part 2 or part 3 to make the toy, I would add them. But that would be a weird toy. If I only need the top, or I could have a toy with just the middle, or I could have, it's the worst toy ever. Like, I don't even know what toy you have, but that would be adding them. So, the fundamental counting principle states that if you need one of each part, but you can only have one of each part. You can only use the fundamental counting principle if you take one of each part. So if I could say, for example, part 1 could be red and white mixed, I wouldn't be able to use the fundamental counting principle. Fundamental counting principle means I take 1, this line means 1 of part 1, and means I multiply 1 of part 2, and I need 1 of part 2. So that when you write that line for the fundamental counting principle, it means you're taking 1 of that part. So if I could take 2 colors from part 1, I couldn't do this, because that line means I can take 1. And so this line means I'm taking 1. The number I put above that line is how many choices I have. It's not how many I'm choosing, it's how many options I have. That's what goes above that. So how many options did I have for part 1? 4. How many options did I have for part 2? 3. So this doesn't mean I'm choosing 3, this means I have 3. This means I'm choosing 1 of them, right? And then I have 2, and I get 4 times 3 times 2, which is 24. Different colored. Yeah? Make sense? So, luckily for you guys, you don't have to show the tree diagram. The tree diagram, though, shows you what actual outcomes you have. So in 30-2, they do the same thing. But they have to show the tree diagram to be able to, because they also take it into probability. So how many of these toys have, what's the probability that the toys have a red, I don't even know where red falls, a red part 1, okay? So how many of them have a red part 1? 6 out of 24, 1/4 of them, right? So then you'd want to be able to visualize them. So the tree diagram is better when we talk about probability. You guys don't do about probability. But I want to do the tree diagram so you didn't just trust me, oh, it's 24. You can see why it's 24. You can see why the fundamental counting principle works. Okay? Okay, next page. As you read through the examples, you're going to be like, this is the dumbest thing I've ever heard in my entire life. Cool. Deal with it. So it's not going to get any better. It's just going to stay like this. So here we have a school cafeteria offers sandwiches made with fillings of ham, salami, cheese, or egg on white, whole wheat, or rye bread. Now this is where we can decide if we can use the fundamental counting principle or not. It says how many different sandwiches can be made using only one filling, and means what do I do when I use the word and? Multiply. One type of bread. So if I'm choosing one filling and one type of bread, what can I use? Fundamental counting principle. So I get one blank. This is the filling. This is the what? Bread. And what do I do with these two blanks? I multiply because I'm using the word and, correct? When I draw that line, it means I'm taking one filling from how many? 4. So this is the number of options above. And this is I'm taking one type of bread from how many? 3. So how many different sandwiches can I make? 12. And you need to write it out. 12 different sandwiches. People leave it like that. 12 different sandwiches. 12 different sandwiches went to the market. 12 different sandwiches stayed home. 12 different sandwiches had roast beef. No, biggie. No. Thanks. I'm funny. Yeah. This isn't super essential. At a minimum for the diploma, you need the blank with the number times the blank with the number equals 12 different sandwiches can be made. The reason why I write the bottom is just so people know what they're finding. Yeah. Okay, example 3. A Math 30 quiz consists of 8 multiple choice questions. So how many parts does this test have? 8, right? It's 8 parts. People are like, no, it has 1. It's multiple choice. Cool. Multiple choice is how many parts? 8. And when you get a multiple choice test, do you have an option to like write 4 of them if you so choose, or 2, or 1? You're like, I really know only 1. So I'm going to write this one, and you're only going to mark 1. Is that a thing? Is that how multiple? Wouldn't it be sweet? Yeah, that's not how it works. You have to do all of them. So we have question number 1, and we have to do question number 2, and we have to do question number 3, and we have to do question number 4, and number 5, and number 6, and number 7, and number 8. All right. So I am choosing one answer to be correct, right? That's why I can do the fundamental counting principle. Each of those lines has one answer correct. You don't have like 3 out of 4 multiple choice. That would be sweet as well. That's not a thing. You have one correct answer. So I have how many different sets of answers are possible if each question has 4 choices, A, B, C, or D. So I'm going to choose one correct answer, but out of how many? 4. And one correct answer out of 4, then 4, then 4, then 4, then 4, then 4, then 4. And a whole bunch of people tell me that's 32. And I'm like, oh no. Oh no, 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 no. 32 is 8 times 4. This isn't 8 times 4. What is this? 4 to the what? Power of 8. Type it in. What large number do you get? Rachel, what did you get?
65,536.
So, for the people in the back listening, I just said that, it's not the people in the back, you guys are perfectly fine. For the guessers, the lazy people who don't study, and they're like, I'll do fine, it's an 8-question quiz, it'll be totally cool, I'll do fine. You have a 1 in 65,536 chance of getting 100 by guessing. Because this 8-question quiz has 65,536 different answer keys that could be made, right? Think about it. It could all be A's. Then you could have an A and it could all be B's. You could have an A and the rest could be C's, then A, then all D's, then an A and then a B and then all A's. And first off, you probably miss, if you're going to try and do it by like examples, you're going to miss a couple. When you're trying to go A's, A, B, like 65,000 you're missing. You also don't have time on a test to do that. But you know what I mean? Like, it's substantial. You don't think about how many answer keys there are. So if you have like a 14-question test, it's going to be 4 to the 14, right? All right. So I want you guys to think about this. I'm going to give you a side question. It's an 8-question quiz. Same thing. 4 answers for each question. Mrs. Lepp has an answer key. It's like this. It's like 1, 2, 3, 4, 5, 6, 7, 8. And normally they won't make you visualize it. And it's A, and it's C, and it's D, and it's B, and it's A, and it's D, and it's C, and it's C. But you don't know that if it's on my desk, right? Just sitting there, waiting to be marked with all your answers. And then I go, poof, and I hit my copy, and it just falls all over it. And it washes out question, answers, those. How many different answer keys are possible? Try it out and discuss it and do whatever you want. If that's what's left, how many different answer keys do I have possible? And the answer is not the same as the previous one. Okay, how many parts are there still to this test? 8. That didn't change, right? So I have 1, 2, that's an eraser. I have 1, 2, 3, 4, 5, 6, 7, 8. I still need to do all of them. So I still need to do question 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Yes? Above the line, I'm still only picking one answer to make it a correct answer sheet. Yeah? How many options do I have for number 1? 4, because I don't know if it was A, B, C, or D. It's gone. Correct? How many do I have for 2? 3, 4, 5, 6. It is what it is. It's D. 7, 8. So it's 4 to the 5. Okay? Okay, what I want you guys to do is move ahead to, sorry, this page. I don't know if they're numbered. Number 3. These are the homework questions. Your homework questions are not going to be in the textbook. They're going to be embedded in here. Your homework questions for the next one are another sheet of questions, so I like having choices. What I try and do is maximum every day have at max 10 questions for homework. Sometimes it's a couple more because I literally can't, I have to get all the topics in, and we have so many that you get like 12 or something like that. Today we did a lot of talking, so that's fine. But your homework is going to be handed in before your unit exam in one spot in Google Classroom. So every day I'll add what the questions were that was. So if you missed that day, go into the homework and look and see what's added for August 28th. Okay? And it'll tell you what. If there's nothing in there, then there was no homework for that day. Okay? So you're working on 1, 2, and 3. I'm also going to add the worked out solutions for the homework into Google Classroom, and I'm going to add you into Google Classroom. Now, why do I add homework solutions? So that you can copy? No. If you copy, I will know you copied, because your matrix, those little quizzes, those 5-question quizzes, and the unit exam will be terrible. Because you learned nothing, you copied my work. So why would I put the homework checks, or put the worked out solutions in there? It's not for copying. So you can check your answers, and say you go to the back of the textbook normally, and you check it, and you don't have the same answer. What do you do then? You try again, see if you can figure out where the error is, and then you spend like 30 minutes of your life on it, and you don't get those 30 minutes back. Then you come in the next day and you're asking me how to do them, but you have period 1, so you're trying to hear at 8, so you can figure out how to do your homework so that you're ready for the next day. Or if I had the worked out solutions, what can you do? Go and look, right? If you're looking at every single solution, how to do it, that's a hint that you should probably come in and get help. The only day I'm not here for scheduled help and lunch is Tuesdays, because I've scheduled help and lunch supervision all outside in the front parking lot. So I tried to make it all one day, so it's all out. But Mondays, Wednesdays, Thursdays, I'm here at 8 a.m. every day, and I'm here for scheduled help and lunch. Also, if you just see me in here, ask a question. I don't know. Okay? All right.
For the next